Welcome to The Explainer. If you've ever even thought about learning to code, but you've been stopped by that one big question, do I need to be some kind of math genius? Then you're in the right place. We're going to break that whole myth down.
Okay, let's just dive right in. This is the question, isn't it? It stops so many talented people before they even write a single line of code. There's this fear that if you weren't a math whiz in school, you're basically locked out of the entire world of programming. But is that actually true?
Well, the reality is a little more interesting than a simple yes or no. The idea that you need zero math, yeah, that's a myth, but so is the idea that you need a PhD in it. The truth is, math isn't some gatekeeper. It's a powerful toolkit that can help you write better, smarter, and way more efficient code. It really helps you unlock the secrets of the digital world. To really get this toolkit idea, let's picture it as a pyramid. We're going to start at the very bottom, the foundation, with the math concepts that every single programmer uses, whether they even realize they're doing it or not. At its absolute core, almost every program you'll ever write or use is running on basic arithmetic. Addition, subtraction, multiplication, division. These are the fundamental building blocks for doing anything with data. From calculating a user's age to figuring out the final price in an online shopping cart, it's all just arithmetic. And what's so cool is how clearly you can see the connection right here. A simple math formula we all learned, area equals length times width, that translates directly into a working line of Python code. See? It's the exact same logic. You're just speaking a different language. Okay, next up is understanding how computers actually think about numbers. We humans use a base 10 system. We've got 10 digits, 0 through 9. Computers, though, they use a base 2 system, which is called binary. It only has 2 digits, 0 and 1. And getting your head around this is really crucial if you ever want to work with hardware or do any low-level programming. And this just shows how programming can make really complex-sounding tasks super simple. With just one line of code, you can instantly convert a number we understand, like 42, into its binary form. That's how the computer truly sees it. And finally, at the base of our pyramid, we've got Boolean algebra. This is the absolute heart of all logic and decision-making in your code. Every single if statement, every condition that tells your program what to do next, that's just Boolean logic in action, figuring out if something is true or false. So let's climb to the next level of our pyramid and see how all this builds. This is where math stops being just, a requirement and starts becoming a full-on superpower for writing code that's fast, efficient, and genuinely intelligent. Now, logarithms might sound a little scary, but think of them as your secret weapon for speed. Here's a crazy example. An algorithm like binary search, which is based on logarithms, can find one specific item in a list of 1,000,000 in just 20 steps. A simple search, that could take up to 1,000,000 steps. That's the incredible power we're talking about. So how do developers measure that kind of efficiency? Well, they use something called Big O notation. It's basically like a report card for your code's performance. It tells you how much slower your code is going to get as you throw more and more data at it. And trust me, understanding this is a huge skill to have, especially in job interviews. Okay, now we're climbing to the very top of the pyramid. This is where specialized, more advanced math becomes absolutely essential for some of the most exciting, cutting-edge fields in programming today. So if you're looking to get into the world of data science or AI, then statistics is pretty much non-negotiable. And as you can see, we're talking about everything from the basics to more advanced stuff like regression analysis for finding trends, or even Monte Carlo simulations to model the probability of really complex outcomes. And for anyone out there who dreams of building the next blockbuster video game, this is your world right here. Linear algebra is literally what lets you move and rotate 3D objects. Calculus is what helps you create realistic motion, like a perfect jump. It's the math behind all the magic you see on screen. And as computer engineer Vanessa Tellez points out, this isn't just a nice to have. For a field like game development, you really need a deeper understanding of both the math and the physics behind it all. It's often a core requirement for the job. But the specialization doesn't stop there. Even things you might not think of, like databases, are built on these mathematical principles. They use something called set theory, like Venn diagrams, to manage huge collections of data. And cryptography, the thing that keeps all your data safe online, that relies on some seriously complex number theory. So, after climbing this whole pyramid, from basic arithmetic all the way up to advanced calculus, what's the big takeaway? What should you bring with you on your own coding journey? Here it is, the most crucial point. Stop seeing math as a wall you have to climb over just to get into programming. Instead, see it for what it is, a collection of really powerful tools. You just add them to your belt one by one as you need them. A developer named Slobodan put it perfectly. The best way to do it is to learn what you need when you need it. Don't let the fear of math stop you, because chances are, when you run into a really tricky problem, mathematics has probably already figured out a solution for you. And that leaves us with a pretty fascinating thought to end on. In a future where AI assistants are writing more and more of our code, what's our role going to be? It makes you wonder, will a deep understanding of these fundamental principles, the underlying math, actually become the very thing that sets great human developers apart from everyone else?